learners, welcome to today's lesson. Today we are going to look at area approximation, and area approximation has three methods. One, we have trapezium rule. Number two, we have mid-ordinate, and number three, we can also estimate the area of a certain region using integration. But today we are going to look at trapezium rule. And before we look at the question, I want us to derive the formula that we normally use under trapezium rule, and this is what you are required to do. Assuming you have been given a certain region on a Cartesian plane, that is a region that looks like this, and maybe the region is between x is 0 and 3. This is the x-axis, and of course the vertical here is the y-axis. And you have been told to estimate the area of this region, for example, using 6 strips. What we normally do under trapezium rule, it is to try and get the height first. So to get the height of each trapezia, we are going to get the maximum value of x, which is 3, minus the minimum value of x, which is 0. Then we divide by the number of strips given or mentioned by the examiner. In this case, if you take 3 minus 0, you get 3. Then you divide by 6, you are going to get half, which is exactly 0.5 units. So to get your trapezia, or the strips that you are going to work with, we are going to start with the minimum value of x, then we shall be adding the height so that we can get those strips. So if you take 0 plus 0.5, we are going to get 0.5 here, and this is where we are going to have our first strip. Then to get the second, we take the 0.5 plus the height, which is 0.5, we are going to get 1, and this is where we are going to have another strip. Then if you take 1 plus the height, which is 0.5, you are going to get 1.5, and 1.5 is where we are going to have another strip. You can see these ones are trapeziums. Then 1.5 plus the height, we are going to get 2. That is where we have another one. Then if you take 2 plus 0.5, you are going to get 2.5. And if you take 2.5 plus 3, you are going 2.5 plus the height 0.5, sorry, you are going to get 3. From there, these values of x represents our height, and the vertical lines on the y-axis represents our values, that is the y values. So normally, if you have a trapezium like this and you want to find the area of this trapezium, we know the distance between the two parallel lines will be h, and the two parallel lines, it is a and b. So from there, if you want to find the area of this trapezium in the normal way, we are going to take the half times the height into the sum of the two parallel lines, which is a plus b. Either way, it is the same principle that we are going to use under trapezium rule. That is, the first strip here, we are going to label it y0. Then the second one is going to be y1. This one is y2. This one is y3. Then we have our y4, y5. Then the last one will be y6, since we have 6 strips. From here now, if you want to find the area here, we are going to find the area of the first trapezium. We add the area of the second one, the third, the fourth, the fifth, and the sixth respectively. That is, if I might give them the numbers, we have the first one as A, B, we have C, D, E, and F respectively. So for us to be able to get the area of the first one here, that is the area of A, we are going to have the half times h into, we have the first value of the heights is y0 and y1, which represents A and B respectively. So we are going to have y0 plus y1 Then plus, if you want to get the area of B, we are going to have half times the height into the sum of the two parallel lines, which is y1 plus y2, then plus, if you want to get C, we are going to have half times the height, then into the sum of the two parallel lines, that is, we have y2 plus y3, then plus, if you need the area of trapezium D, it is going to be half times the height into, we have the sum of the two parallel lines, which is y3 plus y4. Then if you need E, we are going to have half times our height into the sum of the two parallel lines, which is y4 plus y5. Then lastly, if you want to get the area of F, we are going to take half into, that is half height into the sum of the two parallel lines, which is y5 plus y6. From there, if you sum all of them, you will have gotten the area of that region anyway. From here, we are going to use factorization to look at what is common. If you look at all this, you realize half is common everywhere. So we are going to factor half h outside because it is here, 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 everywhere. Then from there, you realize, if you look through keenly, you realize y0 and y6 are only appearing once, but y1, y2, y3, y4, and y5 are appearing 2 times. And therefore, to simplify this formula, we are going to factor half h outside into, we have y0 plus y6, then plus, you realize y1 to y5 appears twice, and therefore we are going to have twice into, we have y1 plus y2 plus y3 plus y4 plus y5, and if you do that, you'd have gotten the area of that region. From here, you can easily forget this formula here, and in summary, if for example you want to calculate the area, in the easiest way, you simply take half times the height into, if you look at y0 and y6, these are the ends. Therefore, we are going to have half h into the sum of the ends, then plus twice, if you look at y1 to y5, they are in the middle, and therefore we are going to have twice sum of middles. And by so doing, you'll have gotten the area of that particular region, which will be in square units. For us to understand how this formula is applied, let us go through the question that is on the board. The question reads, find the area defined by the curve, that is, we have y is equals to x squared plus 2x minus 3, and the lines y is equals to 0, x is equals to -6, and x is equals to -3. Those are the boundaries by trapezium rule or trapezoidal rule using 6 strips. So the easiest way of doing this question first, as we have said, under trapezium rule, the first thing we get is the height. And for us to get the height, we take the maximum value of x, which is of course -3, minus the minimum value of x, which is -6. We divide by the number of trapezia, or the number of strips mentioned by the examiner. If you work out this one here, -3 minus minus, of course minus minus is a plus, and therefore -3 plus 6 will give us 3 divided by 6, and this one is going to give us half, which is 0.5. units. After you have gotten the height, you simply come and develop a table here. You develop a table with the values of x, and of course we are going to get the y's. We are going to get the y's. Once you develop the table, we begin with the minimum value of x, which is minus 6. Then we shall be adding that height so that we can get the next value of x in that order. So if you take negative 6, you add the height, which is 0.5, we are going to get 5.5. Then you take 5.5, that is negative. You add 0.5 units, we are going to get negative 5.0. Then if you take negative 5, you add 0.5, you are going to get negative 4.5. Then if you take negative 4.5, you add h, we are going to get negative 4.0. Then you take negative 4.0, you add 0.5 units, you are going to get negative 3.5. And of course, if you take negative 3.5, you add 0.5, you are going to get negative 3. And that is where we are going to stop, because we are supposed to estimate the area bounded by the region which is from negative 6 and of course to negative 3. Once we have the values of x, you are supposed to go and substitute them in our function for us to be able to get the values of y. So what we do, if we take y is equals to x squared plus 2x minus 3, then you substitute the value of x here. That is, we are going to have the value of y here will be equal to, y is equals to negative 6, that is our x, then it is squared, plus we have 2 times the value of x, which is minus 6, and of course we minus 3, and this one is going to be 36. That is 12. And then from there, of course, we are going to have minus 3, and when you work out that, you are going to get positive 21 anyway. Next, we have our value of x is negative 5.5, and if you substitute negative 5.5 in this function here, we are going to get what value? Let us use the calculator and see what we are going to get there. So we have negative 5.5, and of course it is squared. Then we add twice the value of x, which is minus 5.5. If we minus 3, we are going to get the value that is actually 16.25. Then if you substitute 5 in that same function, if we can do it together, let me show you how to substitute it there. We can take the function which is y is equals to x squared, and our x squared is 5, so we are going to have minus 5 squared plus 2 into the value of x, and the value of x is minus 5. We minus 3. Minus 5 squared is positive 25. Then positive 2 times minus 5, we will get minus 10, and of course minus 3. That means if you take 25 minus 10, you get 15. 15 minus 3, you are going to get 12. Next we have negative 4.5 is what we are going to put here. And when you work out that, you are going to get 8.25. And then next, now you go and substitute the value of x here. And when you substitute the value of x, which is minus 4, you are going to get 5. And then now, if you substitute this value of x in this function here, you are going to get 2.25. And lastly, When you substitute the value of x in this function, it is going to give you a 0. From here, going to our formula under trapezium rule, we are going to take the first value of y here to be our y0, then we are going to have our y1, y2, y3, y4, this is y5, and lastly this is y6. From there we know area using trapezium rule will be equal to half times h into the sum of the ends, plus twice sum of the middles, and by so doing you substitute and get the answer of that. So we are going to have half times our h, which is actually 0.5, we can maintain it as a fraction, into we have the sum of the ends represents y0 and y6, and therefore the sum of the ends will be 21 plus 0, this one will be plus twice into y1, and our y1 is 16.25 plus 12 plus we have 8.5 plus we have 5 plus 2.25. From there we can work out, that is we have half times half will give us a quarter, into we have this is 21 plus 0, which is 21, plus we have 2 times we have to get the sum of this plus this plus this. No, this one was actually 8.25, this is 8.25, and if we add 16.25, you add 12, you add 8.25 plus 5 plus 2.25, you are going to get 43.75, and if you take 43.75, you multiply by 2, you are going to get 87, and therefore this is a quarter into 21 plus 87.5, and if you take 87.5, you add 21, we are going to get 108.5, and this one is going to be a quarter times 108.5, and this one is going to give us 27.125, and since we are not given the units, we say square units, and that is the area of that particular region. Anyway,